All right, I'm going to show you how to implement Rand10 using Rand7. So really quick, let's get some obvious stuff out of the way. We can't just do return Rand7 because then it's impossible to generate the numbers 8, 9, and 10. And we're trying to implement Rand10 here. So and something like when I first did this problem, I just thought, what if I just call Rand7 10 times. So let's just type that out really quick. So I less than 10 plus plus I, and I was sum plus equals the Rand7, and then return the sum mod 10 plus 1, because this would give us some number between 0 and 9. But we want to return 1 to 10, so I just add 1 to put in the range of 1 to 10. So this would work actually. Well, I don't want to say it works. It passes the Leetcode test cases, and I'll explain what's going on in a second. But it's not actually correct. Let me submit it just to show you. Okay, so it does pass the Leetcode test cases, but it's not correct. And this will actually work. Like, I don't have to necessarily do 10. I could do 5 here. If I only called Rand7 5 times, it'll still work. And let's say I made it 7 times. Well, this will still work. Okay, so let me just show you what it looks like, or why this isn't actually correct. Because in the problem, what they're asking for is, there's a specific word I'm looking for. Oh, here we go. So write a function, Rand10, that generates a uniform random integer in the range 1 to 10. But this isn't actually uniform. This is like pseudo-uniform, because what we're doing here is we're just, by calling Rand7 like a bunch of times, is we're essentially equalizing the number of possibilities that each digit can occur as a remainder when we do this sum mod 10. And just to like prove it, one of my friends in a meetup group or whatever, he actually like wrote out some code where he wanted to see what all the possibilities were, and he checked out what the different, like, what was the percentage of each digit occurring. And these are not, if it was uniform, these should just be all exactly 10%. But they're all, this is like 10.001%, 9.99%. So it's very, very close to being uniform. It's like, I would say it's pseudo uniform. So this represents like digit 0, digit 1, digit 2, all the way to digit 9, being able to, how often it can occur in terms of like a percentage. So 10% of the time, 10.001% of the time is 0 would occur, and etc. So, but it's not exactly uniform. It's pseudo-uniform. So I just wanted to point that out there. So we're not going to do like that. So we're going to get exactly uniform. We want exactly 10% of the time we want to return a certain number, or return a digit between 1 and 10. So let's actually walk through some logic. Let's say I gave you Rand20. If I gave you Rand20, well, and we could just do return Rand20 mod 10 plus 1, right? Because the digits, because if we look at like what are the possible numbers in here? If we have 1 to 10 and 11 to 20, and I do mod 10 of each one, well, you can clearly see that like the probability of getting a 0 or 1 or a 0 or 1 in this set, I'm sorry, 0, 1, a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, from 0 to 9, the digits 0 to 9 have an equal chance of occurring one time here and equal chance of occurring one time here. So they have each digit, if I take it like the remainder digit, which would be 0 to 9, they each have 2 shots at occurring, 2 opportunities to occur. Either it's in the 1 to 10 or 11 to 20, which is why this would work. But let's say I gave you Rand22. If I gave you Rand22, well, now you have these extra numbers, 21, 22. And now what ends up happening is you have this 1, when I do mod 10 of this 1 and this 2, they now have a third shot at occurring compared to the numbers 3, 4, 5, 6, 7, 8, 9, and 0. They only have 2 opportunities to occur. But yeah, they basically get so this is no longer uniform now. If we were to just do Rand22 mod 10 plus 1, because the 1 and 2 have a third opportunity to occur compared to the other numbers. Okay, but what we could do is, if Rand22, or let's say we did, we start this in a number, int num equals Rand22, and if the number is less than or equal to 20, then we could return num mod 10 plus 1. And what we're essentially doing here is if it's greater than 20, so 21 or 22, we just ignore it. We're going to ignore it and we're going to try again. So we could do like a while true thing here. While true, do all this. Okay. So we would just keep, anytime we get something that, like any numbers that break that even distribution of numbers that we want, we just throw it away. We just ignore it. So that's essentially the algorithm. But so yeah, let's just get into it. So we have Rand7 here, right? And before I was giving an example of, Rand22, but the problem with, well, Rand22 is greater than Rand10, or 22 is greater than 10. So we have enough numbers that we can choose from. But with Rand7, we don't even have enough numbers to choose from. So what we need to do is, in the basic approach, we could just call Rand7 twice. And if you think about it, there's 1 to 7 possibilities here and 7 possibilities over here, right? Because we could generate any number between 1 and 7 here, any number between 1 and 7 here. And if you think about what are all the different possible combinations of these outcomes, so like we could have, like, say we could generate a 4 here, and then we generate a 5 over here, or a 3 or a 2, whatever, a 1. Well, the number of possibilities, if we were to mix and match 2 calls to Rand7, is just 49, because if there's 7 possibilities here, there's 7 possibilities here, 7 times 7 equals 49. Cool? So, and if what essentially is what we can do is we can actually build Rand49 from Rand7, or 2 calls to Rand7. So, and if we have Rand49, what we can do is check if the number that we get is less than or equal to 40. And if it's less than or equal to 40, then we could do the whole mod 10 plus 1 to get a number between 1 and 10 uniformly. And then a number greater than 40, so 41 to 49, 41 to 49, throw it out. Or just throw it away, ignore it, whatever. Okay, so let's actually get into the code here. So int, or we're going to say while true, because we're just going to keep trying over and over again to get a number that is less than or equal to 40. So we're going to say int result equals, and I'm going to explain the math here in a second, but we're going to say 7 times Rand7 or minus 1. And I'll explain this in a second, don't worry. Plus Rand7. So what's going on here? So here I'm saying this will give me, so let's just look at this right here. Rand7 is going to give me a number between 1 and 7, and I subtract 1. So that's going to give me a number, this whole thing is right here, is going to give me a number between 0 and 6, which means I'm generating between 0 and 6 sevens. There's, in the number 49, there are 7 sevens, right? And I'm just saying, okay, use the first Rand call to give me the first 6 sevens, or 0 to 6 sevens. So some number between 0 and 42. And then I'm going to just make one more call to Rand to give me that 7th 7. That's how I think about it. So yeah, let's keep going. So if our result is less than or equal to 40, wonderful. Just return result mod 10 plus 1, right? Because this will give me some number between 0 and 9, and we add 1 to put in the range of 1 to 10. Okay, and I think this will work. Let's just try it out. Okay, submit. Okay, cool. So this works. And now let's talk about the time complexity here, and then we're going to optimize this. So time complexity, so in the worst case isn't too interesting. So worst case is just going to be O infinity. And that's because, while true, our result, we could technically just keep getting 41 to 49 over and over and over again, even though, like, realistically it's not going to happen. But, in the worst case, it is technically O of infinity. Okay, but now the average case. So the average case, let's call that average. Let's talk about how many calls we're going to have to make to Rand7. So let's go through some intuition here. So if I gave you a 6-sided die, and I ask you, so I have a 6-sided die, and I ask you, and your probability of getting, say, a 4 is 1 in 6, and I ask you how many times would I have to throw this dice to get a 4 on average? Well, you could say that, well, if I throw this die 6 times with a 1 in 6 probability, on average, I'm gonna have to throw this die 6 times to get one successful result, where I get my 4 that I want. So maybe I should type this out in English. I'm trying to debating on how I should type it. But if I throw dice 6 times, on average, we get a success. Cool. We get one success. So that's how I think about it in terms of dice. So now, how do we apply that to, say, that intuition to our problem here? So here we have a 40 and 49 chance of being successful with returning a valid result. Well, actually, let me leave that here. So 40 and 49 chance. Well, that just means that if we were to run this 49 times, so if we were to like execute this 49 times, on average, we're going to succeed 40 times. On average, so if we execute 49 times, on average, succeed 40 times. Just put in a we in there. We succeed 40 times. Okay, so and what that means, and each of these 40 times, we're making 2 calls, but we'll get to that. So let's say, so we're making 2 calls on each of these 40 times. So we're saying on average, we're going to make 2 calls to whatever this comes out to. So this would be, let me just simplify this. So this is 1.225, this 49 over 40. So what I'm saying is, if I were to execute this 1.225 times, on average, I'm going to succeed once. And this is how many calls I have to make, right? Because I'm calling Rand7 twice here. So this would come out to 2.45 calls on average. Yeah, so in order to get we succeed. So 2.45 calls on average, we succeed. And just getting a number that is less than or equal to 40. Okay, so we're making 2.45 calls on average, but the big O just comes out to, well, 2.45 times Rand, whatever the big O of Rand7 is. But we take out the constants, so it just ends up being a big O of Rand7. But I think it is nice to be able to explain like what your average number of calls would be. Okay, so let's get rid of this. And now we can optimize this a little bit. So notice if we have a 40 and 49 chance here, we notice that we're not doing anything with these excessive numbers, the 41 to 49. So 41 to 49 are just getting thrown out. But what we can do is, let's say I take that number. So like let's just call this int a equals result mod 10. So now this is some number between 1 to 9. So I have some number between 1 to 9. And these numbers, 1 to 9, they have an even shot of occurring. They have an even probability of occurring. Because all I did was I took 41 to 49, I just did the mod 10. So these have an even distribution, or an even probability of happening, or whatever. Okay, so what we essentially have here is Rand9, right? So what we have here is Rand9, and Rand9, we don't have enough to get, so we could do what we did before. We did 2 calls to Rand7 before, right? We did Rand7 and Rand7, and this gave us 49 possibilities. Well, now we can do Rand9 and Rand7. Now, how many possibilities do we have here? Well, that's just 9. All right, let me just put it over here. That's 9 possibilities times 7 possibilities equals 63 possible outcomes of mixing and matching these possible numbers. So like, I could get 1 to 9 here, 1 to 7 here, and if I were to mix and match all the different possible outcomes, then that just ends up being 9 times 7 equals 63. Okay, which means that we essentially have Rand 63 with this logic. So let's actually implement this. So if we have Rand 63, or actually let's just type it out. So int a result mod 10. So we're going to say result equals 7 times a minus 1. So what I'm doing is it's like give me the first 8 7. So remember, this is some number between 1 and 9, but I'm going to subtract 1. So this is now a number between 0 and 8. So it's like give me the first 8 sevens, 0 to 8 sevens, and then I'm going to add in the last 7, which would be a total of 9 sevens, or sorry, Rand7, to get 63, or some number between 1 and 63. And I just put spaces there. Okay. So now this is essentially Rand63. And if the result is less than or equal to 60, well, guess what? Now we have a 60 and 63 chance of succeeding. So if this fails, well, now we have a 60 and 63 chance, because before we had a 40 and 49 chance, right? That's obviously worse than having a 60 and 63 chance. This is a lot better. So if the result is less than or equal to 60, then we're going to return the result, mod 10 plus 1. And so we actually have, so you could actually create a Rand21 out of this, because like notice we have 3 left over. So what we would essentially have is at the end we'd have like Rand3 if we did the same thing here, because here we had Rand9 because we took the leftover 9. Here if we took the leftover 3, we'd have Rand3. And if we did Rand3 times Rand21, or sorry, Rand21, Rand7, this would give us Rand21. But having Rand21 isn't any better than having Rand63, because 20 over 21 is equal to 60 over 63, because we wouldn't want the 21, right? Because then 1 would have 3 shots at occurring, versus if we just had 20, everything has an even chance of occurring when we do the mod 10. So and if this isn't clear, if I multiply 20 by 3 and I multiply 21 by 3, I get 60 over 63. That's why they're equal. So what we can do, and because we like this 60 over 63 more than this 40 over 49, we can actually just keep repeating our Rand63 that we have now. So here's what we're going to do. We're going to turn this into a while loop here. And now we're just going to keep repeating our Rand63. And that should, oh my gosh, trying to fix the spacing. Okay, so I think I'm gonna leave that there. I feel like I might be missing something, but let's just run it. I think I got everything. Never mind. What's going on? What's 40 over 49? Did I not comment something? Oh, I didn't comment something out. All right, let's run it. Cool. So that's, oh, it's faster than 99% too. That's pretty cool. But anyway, that's how I would optimize it a little bit. So you could just keep repeating Rand63, just using that sample of 1 to 9. And you'd have to it actually depends on what your remainder is here. Like if we were to change this to like Rand6, implement Rand10 using Rand6 or something, you'd have to kind of think about it. But I think with the intuition, you could definitely work it out if you understand how I got to here. Okay, so I know I wanted to mention something. Oh, right. Okay, so I did say earlier this would take an average of 2.45 calls. So I said earlier average is 2.45 calls. Well, now we actually reduced it. And I'm actually not familiar with geometric distribution math. This is what this is: geometric distribution, and and then expected value. So this would be the expected value, or AKA the mean of a geometric distribution. So let me just type that out in case you guys want to look it up. So expected value, also known as mean of So AKA also known as the mean of a geometric distribution. In case you guys want to like look it up and like, you know, explore this a little bit more. But yeah, I'm not familiar with how to calculate this, I'll be honest. But I do know, but it's obviously less than 2.45 because it was 2.45 without this. And if I optimized it to with Rand63, then it should be like, it comes out to like 2.2 something, I think. But I'm not 100% sure, I'll be honest. Um, I'm not a mathematician. But anyway, the one last thing I wanted to mention, and this is just like a disclaimer, some guy in the discussion section, so that was the basic approach, but some guy came up with a way to get an average of like 1.183 calls to Rand7. And you know how he does it, I'm not gonna lie, the math is magic to me, and it's beyond my mathematical capabilities at the moment. But if one of you wants to make a video on that, by all means. But I'm perfectly fine with the basic approach of just like, or go back to the problem of just like taking a, this is essentially the basic approach and then optimizing the basic approach. But if you want to get into the more mathy way of doing it, then by all means. I just wanted to throw that out there that there does exist even a more efficient way to go about this. Okay, so that is the entire problem, and I hope you guys enjoyed the video. If it helped, you can give it a thumbs up. You can subscribe if you want to make a video like, I make videos like about once a week. But yeah, yeah, thanks for watching. Bye. Yeah, peace.